Hello? Oh, awesome. Everyone, you are all rock stars. Because I just stood here, and I mean, the level of attunement is like I stood here, and all of a sudden the room is quiet now. It's amazing. It's really good to be back at Google. This is a phenomenal turnout. Can I get a show of hands for who's here for the first time? Wow. Man. Just shout out, how did you hear about this event? Meetup?
Somebody asked me to speak.
Awesome. Somebody asked me to speak. Okay, so my name is Alice. I'm one of the organizers of the Data Analytics and Machine Learning Meetup. We have two other co-organizers here tonight. Alex, who is here, David here, and Alex there. We are recording the meetup, and hopefully we will be able to put them up afterwards online for people to consume for all posterity. So we're really excited about the event tonight. We have Craig and Nikhil and Bob from CloudML and TensorFlow from Google to give us the talk. And we also have generous sponsors from Looker who pay for the yummy food. So we're going to have... So would you guys like to come up here and just tell us a little bit about Looker?
Sure.
Thank you.
Should I?
Yep.
All right. Hey guys, can you hear me? Cool. Well, we're really happy to be here. Thanks for having us. We were excited to sponsor the food, and we were even more excited that it was so delicious. Just to give you some background on Looker, so Chris and I actually are headquartered in Santa Cruz, but we work a lot in Seattle. So we thought we'd just spend a couple minutes giving you some background on Looker. If you're interested in it after, you can Google us at looker.com. All right, so just to give you a quick overview of what Looker is, Looker's a web-based business intelligence platform that's designed to give anyone, regardless of technical skill level, the ability to ask and answer questions of data. So from the data scientist perspective, this means that you get to govern the data. There's a central data modeling layer. And then from the business user perspective, they get to ask questions of the data and actually have access to the data. So as I mentioned, Chris and I are in Santa Cruz, but we have offices around the US and in London. Today we have over 700 customers. We're doing a mixture of internal analytics and then customer-facing analytics. So if you want to embed Looker into your product, that's also an option. We have 250 employees who've been around for about 4 years and have lots of funding. So I'll let Chris jump in and just give you a little bit of technical information about what we do.
Cool. So here we have a little overview of our customer base. I think the most important thing to notice here is that we're vertical agnostic. So regardless of the data that you're actually bringing to the table, we're going to be able to model that and leverage that in that self-service fashion or input that information into some kind of application if that's desired. One other thing to note here is that not all clients are only using our UI to actually do this self-service analytics. We also have a fully RESTful API that you can leverage to extract result sets and automate tasks within the application. In terms of some of the things that differentiate Looker from other tools that you may be familiar with in this space, the first is that Looker is 100% in database. So we connect to relational databases and Hadoop infrastructures with a SQL layer on top of them via JDBC connection, and then we write SQL against those databases and leverage the power of these new era databases to run those analytical workloads. The bread and butter of Looker is that LookML modeling layer that you see there in the middle. So that is where you can abstract the definitions of all of your metrics and dimensions using that SQL logic and define all the different relationships that actually happen between your different data sets. Your end users can then leverage that logic that you've created in a governed fashion to create their own reports. The last component here is that Looker is 100% web-based, so in terms of integrating with other applications and using that API, that just facilitates ease around collaboration as well as that application. Typically, as I mentioned, we see Looker being used as a self-service dashboarding and data exploration tool for both technical and non-technical users. But it does have some more developer and data scientist applications and use cases that we can talk about as well. One of those being the RESTful API that I mentioned that you can leverage to automate different tasks and extract result sets from the Looker application. And in terms of extending that a step farther, what we're going to highlight today is one of the ways that you can actually integrate with R and our Look-R library that you can plug in there. So one of the things that you can do is you can leverage the different dimensions and measures that you've created in that modeling layer. You can define all the transformations and do all the data cleanup on the database side rather than in a post-processing fashion. You can then go ahead and actually pipe those result sets back into Looker and compare them to actuals and go ahead and allow end users to actually slice and dice by those predictive models that you may have created. So if you guys are interested in hearing more about how Looker may be applicable to your guys' company or some of the use cases that you have in mind, as Angela mentioned, you can Google us at looker.com. And then you also can reach out to me via email at chris@looker.com.
Thanks, guys.
Thank you.
Hi everyone. I'm Arthur. I'm a software engineer here at Google Kirkland, and on behalf of Google Kirkland, we just wanted to welcome you all, and we're excited that you are excited to learn about TensorFlow and CloudML. And I just wanted to say one thing. I wanted to give a shout out to our 25 volunteers. Stand up, everybody, for the TensorFlow. Questions later on, you can talk to any of the volunteers or have any logistical issues with getting back to your cars or the garage. Find somebody with a TensorFlow t-shirt, they'll be more than happy to help you. All right, with that, I'll turn it over to Bobby.
Thank you. Can you guys hear me from the microphone here in my neck?
Yeah.
All right, cool. Is there a present button or is it already presented?
We, you gotta hit the, we're hiding this switch.
Present.
Yeah. Do it.
Awesome. So thank you everybody for coming to the TensorFlow event. You're going to get to learn a lot about TensorFlow. My name is Bob Day. I don't work on the TensorFlow components, but I work on a thing called CloudML APIs, which is a sibling group to Nikhil, who's going to talk in just a minute. His group works on running the TensorFlow stuff. I work on using it and building particular models, and I'd like to show you those. There's me. Here's our agenda for the time. And so Google ML APIs. So in a normal TensorFlow model, you would bring your data and your TensorFlow graph / model into the world and be able to build whatever solution you wanted to do. Google's done that before for many models, and so off on the left-hand side, you'll see Google models and Google data, where we bring our data and our models. We have a bunch of models already. There's things like the speech recognition, image recognition, translation, and natural language, and you'll see them all. For example, translation. If you go to translate.google.com, you'll be programming directly via these APIs the same thing people would do when they go to translate.google.com, so you can translate from one language to another programmatically. Same thing happens for the speech recognition, image recognition, stuff like that. We have a bunch of APIs. They are the speech recognition API, lets you translate a WAV file into text in 80 different languages. Translation API, 80 different languages from and to each other. The natural language API that lets you do sentiment analysis on a group of text in many languages. Syntax analysis, what's the parts of speech, what's the verb, what's the object. And entities. Hey, this is a paragraph that's about Abraham Lincoln, therefore Abraham Lincoln is called out and a link to the Wikipedia entry for Abraham Lincoln is presented. We also have a bunch of vision stuff that we expose as an API. For example, we do OCR, lets you find text in a picture. There's lots of people who are using it to scan receipts and do that type of stuff, new tools. Entities, if you take a picture of a dog and say, this is a dog. We don't know how detailed the dog canine hierarchy is yet, but we're working on it. We do logos, company logos, landmarks, Eiffel Tower, stuff like that. And we do faces. And we do not do face detection right now, but we do face location and rectangles around the face where we see it in the picture. Lots of fun stuff. Our APIs, actually, every single one of them has what we call a try it page, which is you can actually just go to one of these places and play with the API. And I'm going to do that right now for the speech API. Speech API. The speech API page looks like this and is meant to get you programming against the speech API itself. And where I can show you. Testing, 1, 2, 3. This is a speech recognition.
Just turn this on. Can everybody hear me on the mic? Or?
Yeah.
Yeah, awesome.
And it's actually a lot faster than you see. We have it intentionally slowed down here.
All right, so I'm going to go back. I'm going to present, and then I'm going to switch to actually doing a demo. I'm going to live code. That'll go flawlessly, of course.
Recognition test with confidence of 0.91. Okay? So if you were thinking about using a TensorFlow model to reproduce speech recognition or...
It could go wrong. All right. One small note. I'm actually on a team that's up here in Seattle and Kirkland called Collaboratory, and we work closely with the TensorFlow team. But I'm
or any of the other things, you would probably better be served just by reusing one of our APIs. But I know there's a lot of people out there who are doing a lot more fancy stuff.
I sort of, moonlight on the TensorFlow team from time to time. So I'm going to talk, let me say, to start, I'm just going to sort of talk about what is TensorFlow. So quick show of hands, how many people have heard the word TensorFlow before they came here tonight? Yeah, that's not surprising. How many people actually use TensorFlow for something? Okay, and how many people are like super expert on TensorFlow? I should not raise my hand for that one in some sense, right? Okay, good. So I'm gonna start with something. If you've ever met me before, you can tell a few things already. I like to talk, but I also like really kind of simple things. So I'm gonna do some very fancy stuff tonight. I'm gonna add some numbers. I'm gonna multiply a vector by a matrix. I'm sort of a mathematician by training, so matrices and vectors, I feel right at home. But I'm doing this for a reason, right? I'm gonna sort of walk you through a basic example or two, just so you can get a feel for here are sort of the moving parts in what goes on when I'm using TensorFlow to do something. Here's how I do something basic. Here's how I sort of make that operate on itself and imagine the system kind of operating off on its own. And then I'm going to hand it off to Nikhil, who's going to do something much fancier. And then at the end, I'll say, a few words about other things that go on and considerations for hey, cool, I played with TensorFlow, it was nice, but now I actually want to use this sort of in a full-blown production setting. What are the rest of the pieces and how many of them do I have to invent myself? Does that all seem reasonable? Okay. So I wanted to start by saying, if you've ever done sort of data analysis or machine learning, there's basically this common thing that you have to do over and over, right? You sort of start, you get some data, you spend most of your time cleaning it, you think you're done, you try to do anything with it, you go back to cleaning it, repeat a few times, and then, hey, you finally have sort of some common features that you've pulled out, and you're like, hey, this is the stuff I'm going to use, I'm going to train a model, you train your first model, it's terrible, right? You've all been through this before, right? But it's sort of the same thing, right? So TensorFlow is, sort of one tool here, the original sort of initial stuff that we launched, just solves sort of the modeling and prediction parts of this, right? And then there's more and more of the ecosystem that's sort of growing to help fill out various parts of this. But the whole workflow that you go through, you sort of start, train, evaluate, you deploy this, you start running predictions, and then, something has changed, something is a little different than it was when you started, and you sort of loop back, right? And this sort of thing that we've drawn as a line is sort of actually a line that represents a loop sort of at every point back to any of the previous points. It's like this very terrible game of chutes and ladders that you can't get out of, right? The goal is that TensorFlow makes some of those things much, much easier, and it, over time will hopefully help with more of them as you so choose, but we also try to, where we can, kind of play well with existing other things. So if you don't have to buy the whole religion, you can pick up the bits and pieces that are, that sort of fit where you are struggling with this workflow. All right, so what's a tensor? Like I said, I was a mathematician. I can give you a very different answer if anybody wants to talk about category theory. But that's not the tensors. It's the same thing, but maybe fix a basis and only work over a field. So a tensor for us is just an n-dimensional array. So one-dimensional tensors, very easy to think about. They're vectors. Just homogeneous type, right? Int 32, float, double, whatever it's going to be, right? One type. I've got a row. Does that make sense? Everybody's okay with that? Or, you know, a two-dimensional tensor, I have rows and columns. Usually call it a matrix, right? Everybody still good? Okay. I mean, this should be, you know, reasonable. I just, you know, never heard to say it out loud, right? So, you know, you can also have sort of zero-dimensional tensors, just constants, right? And if you've ever, you know, sort of taken linear algebra classes, or the little, like, you know, numbers that sort of keep getting multiplied in from the front, right? All right, so that's okay. So, you know, we're talking about TensorFlow. We got 1/2, right? We must be close to done. You're not quite that lucky yet. All right. So, so then there's this flow part, right? And the idea is that for a lot of problems, you know, depending on how you do things, you can turn the problem around in your head a few times. Oh, I'm breaking the rules and I'm walking around. You can sort of turn them around in your head a few times, and you can say, hey, so, you know, I want to do some things, and I got to do this thing to a bunch of data in parallel. And I'm doing the same thing over and over, and then I sort of combine these. And for certain operations, you know, it's very different what you do, you know, from sort of like slice to slice. But for a lot of the situations, you know, there's like this very common pattern. You're like, I'm going to take all these things, I'm going to do this thing to them, I'm going to combine them in this way, I'm going to perform this operation, I'm going to, like, you know, split that up and do that with pieces. And if you ever spent time sort of like walking through one of these problems and talking it through, like at a board or on a piece of paper as you were trying to figure out what you were doing, as you try to figure out what you were doing, what you'll discover is you sort of end up drawing this sort of picture, right? So, like, I'm going to have the data come in here, and did it actually mute me?
No.
Okay. All right. Sorry, we got a little note that said I was muted, so I just wanted to make sure. Technical stuff is very hard. You know, we just show up and, you know, wave our hands and draw graphs. You know, what you'll discover is you sort of draw this picture where you're like, well, sort of some data comes in, and I need to go and do this with it, and then there's some other data over here, and I do this with it, and I combine them. So, like, even if you just sort of work with this yourself, you'll end up sort of, at least in your head as you plan this out, drawing this picture where it's like, kind of like a graph, right? Some stuff comes in over here, and I perform this sequence of operations, and I perform some operations on this other thing, and then they combine together in this way, and then I combine in this other piece from over here, and then, you know, I try something, and then based on the evaluation of that, I sort of loop back. And so this idea of basically data sort of like flowing through this graph, this is a very old and well-known idea, right? The idea of sort of like modeling computations, data flow graphs has been done for a long time, but this is where the word flow comes from for TensorFlow, right? So the idea is I take my data, which I'm going to represent as these n-dimensional vectors, right, or, you know, n-dimensional arrays, and I'm going to describe the computation that I want to do as a graph, right? And the thing that TensorFlow does is it makes it easy to take that data, run it through the graph, and basically lather, rinse, repeat. That all make sense? Right? Okay, so that's it. So this is, I mean, I lifted this, you know, I'm very original. I lifted this right out of the original TensorFlow white paper. So this is an example of doing something that's like, you know, at least slightly non-trivial. I'm going to take some matrix and a vector. I'm going to do a matrix multiplication. I'm going to add some other vector. I'm going to apply ReLU, and then there's like a dot, 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 because there could be more that goes on. Right? That all make sense? We're all on the same page? Okay. Cool. So TensorFlow performs computations on n-dimensional arrays. All right? That all make sense? All right. So let's try it. Like I said, we're going to start with some very fancy stuff. I'm going to add some numbers. I might multiply some numbers. I could go so far as to subtract, but I don't want to get carried away. Yeah? We're good? All right. I'm gonna hop over. I have it here, but I'm going to hop over and try it live. And if it all goes poorly, I apologize, and I've got the slides to back up. So here we go. Here I am in a brand new notebook, and I'm in Data Lab, which Nikhil will talk about in a sec. So I'm going to import TensorFlow. Yeah. And so, like all Python libraries, we decided if we really wanted to be legit, we needed a 2-letter abbreviation. So TF was it. We roll with it, right? So pandas is PD, NumPy is NP, we are TF. We totally staked our claim. Yeah. So I can do things, and I can say like TF dot, you can see there's a lot of stuff in the namespace. TF dot constant, and I'm going to say 3 and 4. That's a nice constant. Y is going to be another constant, and I'll say 4 and 3. And so I can say Z is X plus Y. So to be clear, you know, I wanted to work with something that's like very simple and comprehensible, right? What is it going to be when I add these two things together? So I have a vector with a 3 and a 4. I have a vector with a 4 and a 3. I'm going to add them. And I told you these things all happen sort of like, you know, data parallel, right? Like, you know, entry by entry. So when I add those together, what should I get? 7 and 7. Yes. Yes, you guys are awesome. So I try this and I get a bunch of noise, right? So I said that the way TensorFlow works is that we build this graph, right? But the graph simply describes my computation. I need to actually like run some stuff through it, right? So I take this Z and I type z.tab, and you know I'm going to jump ahead because I've done this a few times before. And oh, there's an eval. That must clearly be what I want. this looks bad, right? So I said there was this graph, and I want to evaluate, like I have this thing, tell me what it is, right? Well, you can't just say, hey, I built this graph, go ahead and evaluate. You need a little more information. And a priori, I mean, for an example like this, I don't need any more information. You know exactly what I want to do. We all saw the answer as soon as I typed it up, right? But as you get to sort of broader and broader computations, what you want is this notion of a thing where, this is sort of like the environment in which my computation is going to happen, right? So in TensorFlow, we call that a session, okay? And so what you do, and if you look at, sorry, Nikhil's, he does it all backwards. His scroll is down instead of up. I'm going to be like totally lost, but it's okay. So you can see it says right here, cannot evaluate tensor using eval. No default session is registered. And we have in TensorFlow this tf.session, and because it's Python and we wanted to sort of like try to fit with what a Python programmer would find natural, you say, hey, I have a thing, and I think of this as like the context in which something is going to happen. Right? So this context in which something's going to happen, the way you model that in Python is as a context handler. And now I can say print z.eval. Lo and behold, I get 7 and 7. This is actually all you can do with TensorFlow. This is it. So here we are, right? So we've done a basic thing. We've taken two things and put them together, right? But like just to say it, and I'll say it a few times to drive it home, so that by the time Nikhil does something complex, you at least have a few moving parts that you've got in your head. You've got the data coming in, right? These are the tensors. You've got this graph which describes what it is you want to do, and then you have the session, this like environment in which your calculation is actually going to take place. Does that all make sense? Right? I'm saying this over and over because I spent time teaching intro calc and it like wore off on me, right? But this is all okay? Okay. So sort of going back, I'll just show you the same thing I just said, and I can skip ahead a little bit and go down here, and you can see. So like this is a picture of the graph, and there's a thing called Tensor Board, which is part of sort of TensorFlow, the whole system, and it's a thing that will show you what's going on like while your models are running or after the fact. But like these are sort of small enough that the extra work it would take me to like load that up and show you is silly. So I just took a screenshot, right? So what we did is we built the graph, and then we evaluated. So now I'm going to go one step further. I'm going to give like a little chunk of something that's similar to the slide I showed earlier. I'm going to do a much bigger graph. As you can see, I've got a whole 5 nodes there. We went from 3 to 5. Now we're cooking. Yeah? All right. So, and what I'm going to do is just something a little bit bigger. I'm going to go ahead and add this thing together. So I can even just, for safety's sake, I will just start in a fresh notebook. And I will say import. Ooh, I hit caps lock. Ooh, did I? Oh, import TensorFlow as TF. And now I can say, so what did I have here? I wanted to say X is a, so if you looked at my previous example, I had, I don't know what that is. I had my 2 things that I was adding were constants, right? I mean, chances are, if all you're looking to do is add up a bunch of data that is already fixed, you probably don't need anything fancy, right? So what you need is a way that like new information can flow into this. So in TensorFlow, you've sort of gotten this hint. I drew this graph, right? And there was like the constant had a node for it, right? If I just hop back over here, I have various pictures here, but even in my previous one, each of the constants had a node in this graph, and then there was this bigger node where they came together, right? So everything that goes on in TensorFlow, like every moving part in the computation you're describing, gets its own node in the graph. And there are lots of reasons for this. I mean, one is that like sort of if everything is a first-class citizen, it makes it easier to reason about and how to like operate on these graphs. There are also like cool details about how like, TensorFlow makes it easy to do things like take the existing graph that you ran locally and like split it up and run it in a distributed fashion, right? And one of the ways that it has the power to do that is that if there is this very like sort of homogeneous way in which you've described the work that you're going to do, it has a uniform way of sort of like getting its hooks in the middle. And there's no secret that it doesn't know. It's not like there's a bunch of stuff running that it has no like hand in or control over. There's just like, everything that it's aware of, it has the ability to like, move around or shift between machines or run on a GPU or however it works, right? So as you start to build bigger and bigger things with TensorFlow, you'll discover that, in addition to this basic thing where I've got like a constant and an addition node, right? There are fancier and fancier kinds of operations. So each one of these nodes in the graph we call an operation. So these 2 on the left are these constant operations. They're not very exciting. They are always a constant, right? Hence the name. And the much fancier add operation takes 2 entries and it adds them together. Does that all make sense? Yeah? Okay. So now I'm going to build an even fancier graph. So I'm going to say, and actually, because it'll take me a minute to type, I will copy paste it. So here is my graph, and this is exactly the graph that I had in front of you down here. right? So I have a vector and a matrix, and I'm going to multiply them together, and then I'm going to add something to it, right? So, matrix vector multiply, add something to it. This is, this is a sort of basic operation, but the more time you sort of spend doing machine learning things, you discover that sort of more and more of what you're doing you can sort of model as either, these operations natively or like, things that can be combined from these, right? Does that make sense? Okay, so here I go. I have my graph right here. And so, I can play the same game that I played before. I can say output, it doesn't do anything, but we all know better than that now, right? We're gonna say with tf.session as sesh. So I also said, I went on and on about the constants, but in this case, I would like to actually have something a little bit more exciting, right? Like I don't just want to add constants together. I need to say, here's where new data comes into my graph, right? If I'm gonna be able to flow things through this graph and perform computation and ultimately like have this thing change itself over time, right? This is sort of like the one thing everybody always knows about machine learning. You sort of build a thing and you let it tune itself over time, right? What that means is it needs to be able to feed information back into itself and sort of modify parts of it. So when I tell this that x is a variable and w is a constant, that's exactly this kind of thing. I say that one of these is something that's going to change over time, and one of these is always going to be this constant right here. So if you spend enough time staring at matrices, this is a sort of silly operation. This matrix, if I multiply, it'll just permute the vector, and then I'm going to add 1 to everything. That makes sense? So it's a nice basic operation. So if I just say this, I have to say session.run tf.initialize all variables because there's a variable there and I need to initialize it. So this is one of those things that like looks a little goofy, but becomes second nature once you've done it like 3 times. And then I can just say print, and then what is it? Because now that I'm talking, I'm losing track. Yeah, okay, that was easy. Output.eval, right? What did I say? Up here I said this variable, this is sort of the default for it. So I said it starts out as 0. I permute a row of zeros. I get a row of zeros. I add 1 to everything. I get all 1s, right? Nice and easy, right? So let's do just 1 or 2 more things, and then I promise I will quit going on and on about basic matrix vector operations, right? And let's think about what we really want to do. You want to be able to say like, I have these basic things, so I need to like insert my own data, and then I need to like be able to modify things. So I need to be able to take the things that came out of my graph, use those to go back into the graph, and perform that operation over and over, right? And you will do it with much fancier things than this 5-node graph, right? Like, I will tell you a secret. There aren't a huge number of serious problems you're going to run into in life that are only solved by this, although probably there are a lot, right? Because linear regression is pretty good. Yeah? But, this is sort of the model for what you're going to do. So now I can take this thing, and I can also say, and again, I'm just going to copy paste this. It's a little bit easier. I can say, I will take this graph, and now what I'm going to do is I'm going to pass in, so down here, instead of just saying evaluate the output, I'm going to say go ahead and run this. And in TensorFlow, when you say run this and you tell it run it and give me back this node that I've named, what you're saying is I want to know if you just say this is the node I care about, take the inputs and do whatever you need to with those to like sort of flow the information through the graph and compute my output, right? So here I'm saying instead of just starting with all zeros, put something else in. And I get, so what did I do? I rotated this 1, right? So instead of 3, 4, 5, I had 5, 3, 4. Then I had 1 to everything. 6, 4, 5. Whoa, exciting, right? Does this all make sense though? The goal here was not to show off that we can permute vectors. The goal was to say like, I can do a slightly more complex thing and it all makes sense. And I can even go sort of like, 1 more with this. And I can say, iterated output is this guy, and then I can say for something in range 10, I'm going to do iterated output is session.run output, and now what I'm going to do is the real trick. I'm going to say for x, which was x is this x right here. It's literally like this is the place where you're putting this data in. Instead of just saying it's a fixed value, I'm going to say put the old output in as the new input. Does this make sense? And then at the end, I'm just going to print iterated output. All right? So what happened here? What I said was, take this thing, take the output that you get out, turn around and put that back in as the input, and run the graph over again. All right? So I just took the exact same thing I did to do it once, and I did it a bunch of times, right? And so now you can imagine like, hey, I'm going to build this graph. It's going to describe the thing that I want to do. And these are the parts. I'm going to label the parts that I want to be able to change over time as variables. I'm going to label the parts that don't change because they're staying constant as constants, right? And I mean, there are more than just these two, but for the sake of conversation, I just wanted a couple things to work with, right? And I sort of imagine taking this thing and operating on it, repeating this, evaluating some function at the end, and sort of do that until I get where I want. Does this all make sense? Right? So these are all like, I mean, to be clear, these are like utterly toy examples that are far too simple compared to like what you're actually going to do. What you're really going to do is build much larger graphs, right? Like the inception graph that they use for image recognition has, hundreds of nodes, right? You're not actually going to build that by hand, and Nikhil's going to talk about that in a sec, right? There are more tools that you get, but like fundamentally, sort of the kinds of operations that you've got are like, I'm going to model my computation as a graph, I'm going to run it, I'm going to take what comes out and put it back in as I need, and through this process over time, I can, let this thing iterate on itself and build up something more sophisticated. Does that make sense? Yeah? Okay, cool. If that actually made sense, then I'm happy. I feel like I did some work here. And, so this is it. This is what I was going to do for the first part. So we've got tensors. Those are n-dimensional arrays. We've got graphs. This is what you're going to do with those n-dimensional arrays. And then you got the session, which is the context in which you do it. All right? And these things can all feed on themselves. That all makes sense? Okay, cool. Nikhil, you're up. There are like 5 waters up there as well. I'll just move the other ones for you.
All right, is this working? Can everyone hear me? Yeah? Good. Yep, I'm Nikhil Kothari on the cloud machine learning team, and as well as the data lab team, and I'll talk about both of these things today. You saw a little bit of data lab. Let's start. Cloud machine learning, we like to think of that, thanks, Arthur. We like to think of that as TensorFlow as a service. And so all the things that you just saw with matrix and sort of tensor computation graphs, we want to bring that to you to create real models and do it at scale. And we want to allow you to focus on your models, so we take care of all of your running your code, doing it at scale. You get to focus on your modeling and your data. And then once you've trained your model, we allow you to, we host it for you so that you can run predictions. And we'll see a little bit of that as we go along. As part of Google Cloud Platform, we also let you sort of integrate the rest of the platform. So TensorFlow is sort of that piece that lets you do training, prediction. But there's, where's your data? It's in cloud storage, or it might be in BigQuery. How do you work with it? How do you process it? We have tools like Dataflow, which let you build MapReduce style pipelines, as well as streaming pipelines, as well as Dataproc, which has Apache Spark. So that's how you get to work with your data. How do you collect your data that you might use for training? We have something called Stackdriver to collect your logs. That's an important part of this sort of big machine learning problem. And then you need tools. How do you work with your data? And so we have the data lab. And so that's sort of Google Cloud Platform brought along with TensorFlow to make machine learning possible. So you've seen Data Lab a little bit. Data Lab is a project built on top of Jupyter, which is interactive notebooks. How many people have used Jupyter or notebooks? A bunch of hands. Great. What we've done is brought that familiar open source project, that nice paradigm for working with data, and connected it with Google Cloud, as well as created an environment which has a bunch of things that you typically want, and made it ready to use. We'll see a little bit of that as well. And you can run this locally on your laptop. You can run it on the cloud. All of that's possible. So here's this. Well, let's actually switch over first. So what I'm going to go do is start with where Craig left off, with just sort of tensors and graphs, and try to do something real with it, right? So using TensorFlow to actually produce a model. I'm not going to do something like a crazy fancy model. I'm just going to pick Hello World, which is Iris. Many of you have probably seen it. It's sort of beaten to death, but it really is simple and nice to get started with. Yep. Is that good for everyone in the back? Yeah. Okay, so let me just go ahead and read any previous output. So one of the things that you'll notice here before I get into TensorFlow itself is a whole bunch of libraries like Pandas, short form PD, scikit-learn, which has data sets, some data sets including Iris, Seaborn, which is a visualization library. These are all sort of common things in the Python data analysis and sort of visualization ecosystem. And so you can use all of these alongside TensorFlow. So let's look at this. I'm going to here's my datasets.load_iris, which is from scikit-learn, and I'm just going to do a little bit of sort of cleanup and sort of creating a CSV file and load that up. We'll see that in a second. So here's where the stuff really begins. So I'm going to take the pandas library and read that CSV file in, and we'll see what gets loaded. So if I look at my data frame, that's that data frame. Iris, for those who have not seen, is a very simple data set. It has 4 features, which is sort of measurements of various parts of a flower, and 3 species of iris types labeled for all of those data points. And it's a relatively small data set, just 150 rows, I think. And so we've also gone ahead and split it into 2 parts, a training set and an evaluation set, and you'll see how I use them. One of the first things that you'll do in any machine learning problem is actually look at your data, try to understand it. And so one of the techniques is just sampling your data and getting a sort of a very quick sense of it. Of course, with any real data, you'll have lots more columns, you'll have a lot more interesting things going on, and so this is where the power of interactive notebooks comes into play, where you can actually start visualizing your data and seeing patterns, which is a great way to kind of understand your data, and then be able to sort of figure out where you want to zoom in, slice data, go further. The thing that you're seeing with Data Lab here is this environment had all of these tools. You're able to bring in your data and start applying these standard tools and start working with the data. So this chart here just sort of produces the distributions of the data based on the different species, that's the colors, and looking at correlations. There's obviously many more techniques around visualization of data that you might apply to your problem. So now let's get back into TensorFlow. So you saw that little graph with multiplying 2 matrices and adding. That's a basis of a very simple linear model, and I'm going to do exactly that. And I'll relate back to what Craig was saying. So I'm going to build a graph. In this case, I'm not going to sort of build this graph in the ether. I'm actually going to go create a graph variable. So tf.graph creates a variable, graph instance. And I'm going to go ahead and start declaring those tensors to represent the different parts of my model. So here's where I've created placeholders. So you saw constants and variables. The placeholders are a place where you can feed in data later. And here's where I'm going to go ahead and create a few variables that I'm actually going to learn as part of my training. And then here's where I'm going to multiply those 2 and add the bias. Now, that's sort of just computing a basic sort of linear equation, effectively, of these tensors. In order to do training, I'm actually also going to go ahead and start, as I feed data, I'm going to look at, did the output of this linear equation match the expected output, or the sort of target label, the species, and compute something called loss, which is the error, effectively, that I want to minimize during training. Using a optimizer. There are several different kinds of optimizers. This is one that is a good one to start with. And my training operation basically going to say, run all this through in sort of as I'm using this graph and minimize this loss. And you'll see, I'll come back to how this is used. So let's execute this. So like you saw before, all I've done is create a graph. This sort of iris graph is basically in memory. No computations actually happen. Now I'm actually going to write this computation loop itself, so the train method. Basically, it's going to have a loop for, step through 1,000 times. Look at my training data, so this data frame that contains my training data, and take 50 rows from it, and take a batch, that's basically called a batch of data, and create my feed dictionary, you saw that earlier, and call session.run, passing in that feed dictionary. And what the operation that I want to run is the train operation. So what TensorFlow does is it figures out, okay, well, you've told me to run this, and feed in those pieces of data into these placeholders, and so it's going to run all operations in the graph that are needed to evaluate this particular operation. And so that's what's going to cause these sort of things to run. It's going to cause these things to run as well. The loss has been computed, and then it's going to get minimized or optimized. And then what I'm going to also do is every 10th time, I'm also going to feed in the evaluation data, and I'm going to see how well the model has learned to predict over the evaluation data. So in this particular case, I'm going to, instead of running the, oops, sorry, scroll away. instead of running the training op, I'm going to run the summary op and the accuracy op and feed in this evaluation data. And you'll see the summaries come into play just in just a second. So let's just actually go ahead and run this. Now I'm going to go ahead and create that session. And I'm going to pass in the graph that I defined, that iris graph, as the graph to use for the session. And then call train. And this will take just a second. It's a tiny problem. And one of the things that was produced is this summary. And think of summaries as basically a way to log what is happening during the train. So this is sort of equivalent of sort of log every time you're in the loop, but you'll see it produces some interesting visualizations. One of the tools in this TensorFlow ecosystem is called Tensor Board. And so I'm going to go ahead and start it. And launch it. And so what you'll see is those, so I had a couple, let me show where these things come from. So if you look at my graph as I was building it, I was outputting a few things as summaries. I was outputting the loss and the accuracy as the graph was being trained into this summary log. And that's what I can see here. I can see over the course of training, my accuracy goes up, my loss goes down. I ran 1,000 steps. You can see distributions. This is sort of, the distribution of my bias variable that I learned. This is the distribution of my weights that I learned. You can also see the graph. And so this is sort of that same tiny graph, but a lot more around it. And here's the input, here's my features and my target. Here's the inference, and you can sort of see what's going on with each of the operations that you did, right? So this kind of gets you a sense of what's going on. And the way this graph is sort of made to look sort of manageable is if you look at the way I constructed my graph, I name-scoped everything as I was doing it. So, my input is name-scoped as input, my inference code was namespace as inference, and that helps me group all the sort of operations in this graph when I go to the Tensor Board visualization. All right, so what I've just done is I have run a bunch of training data through a graph in a particular session, right? And so those variables have been learned, and so now I want to use them. So I can go ahead and create a single instance of data, but no species, right? It's just those 4 features. And I'm going to go ahead and read that into a data frame. And then I'm going to go ahead and call predict. So predict was the second method. So again, I'm creating this dictionary, this feed dictionary that I'm going to feed into the session. And this time around, I'm saying, run the tensors that are prediction and score. That's right up over here. The outputs. And go ahead and feed that dictionary into the graph. And then I'm going to just do a little bit of pandas sort of stuff to take the input data and the output scores and sort of join them. So let's run that. And you can see it takes those features and tacks on prediction and score associated with that prediction. Right? So I trained something and now I used it to predict something. That is sort of a very fundamental building block that you can then use to start evaluating a model. Now, I can take my evaluation data and run it through the same predict method. And now I have, in the evaluation data, I actually have a target, the expected target. That's the species, and that's the prediction. What I can do with this is build a confusion matrix, which is one of the standard tools used for understanding how your classifier is doing. So it's sort of, you read it, here's the target on the Y and the predicted. When the species is Setosa, how many did I get correct and how many did I get incorrect? And this is sort of a good way of seeing, how your model is doing at a sort of summary level. Of course, this is a very simple problem. It did pretty well. I think it got 1 wrong. But you can see also, sometimes it's interesting to see which instances it got wrong, and you can start doing various things with the data using standard tools like scikit-learn as well as pandas data frames. All right. So that's sort of a very quick walkthrough from going from tensors to a model. Any questions? I'd love to make this interactive and before I go further. will keep going. The next step is to look at starting to do this in cloud, right? We obviously want to do interesting things with this and train real models. So let's close off this notebook. Let's close this. So let me go back to this slide and add a little bit of context. So we just saw a little bit of training, a little bit of prediction, but the machine learning workflow is, one of the important things is about preparing your features, going from raw data into stuff that, into data that can be turned into vectors that you want to feed into your model. So I'm going to show you a little bit of that and what we offer in cloud to do that at scale, training as well as prediction, right? So let's start, again, of course I'm going to continue with the example and do iris, and this is sort of toy example. So one of the things I'm going to introduce here is pre-processing. So we have this iris data, the same 4 features. One of the things that you might do very often in machine learning is take your numerical data, figure out the range, normalize it. This helps in a variety of models. And of course, that's just one of the things that you do in pre-processing. There's, you might binarize your data, you might bucketize your data. If you have text, you might actually do some tokenization. There's lots of sophisticated things. What we offer with cloud machine learning is an SDK that allows you to model your features and perform those pre-processing transformations on your data, both locally while you're developing with a sample data set, as well as on cloud with Cloud Dataflow. All right? So let's get started. So I just imported Apache Beam, which is Cloud Dataflow. This is an Apache project. It started over here at Google and was being worked on further as part of the Apache Foundation. So I'm going to go ahead and define a class that declares a bunch of things about my data, the schema, like the columns, which column is the target, which columns are the features, and what transformation to perform on them. So I've just defined this. And then I'm going to go ahead and define a pre-processing pipeline. And this is, for people who haven't seen, it's Dataflow code. This is sort of a fairly simple pipeline, but you can do all sorts of things. You can bring in your own code to do custom transformation. You can read from different sources. I'm going to just read from a text file. You can read from BigQuery. You can read from other data stores. So I'm going to go ahead and define my sources, my training source, which is the training data, and evaluations source, which is go ahead and read it. And so this is, again, I'm actually declaring a graph again. Just like TensorFlow, Dataflow has the same sort of concepts. I'm declaring a graph that says, go ahead and read the data, then go ahead and pre-process the data. After this pre-processing is done, write out a bunch of statistics like the ranges of numbers and what columns were there and things like that. And then write out the features. So again, just go ahead and declare this graph. Then I will go ahead and create a pipeline. This is sort of similar to a session in TensorFlow, right? And I'm going to give it some variables, like the inputs and outputs, and I'm going to tell it to go run. And that will sort of figure out the map reduces it needs to construct behind the scenes, optimize the graph, do things in parallel, and sort of execute that. So let's go ahead and execute that. In this case, I'm executing it locally. So this is sort of, you choose where you run it with different runners. And this is executed. Ignore that warning. And you'll see it produced a bit of output. It produced, this TF record files, which are, think of TF record files as a way to package up your features. So all of those numeric data that I had in the CSV can be represented as examples that can be read efficiently into TensorFlow. And then they're compressed, so that's why the gzip. So this is sort of a very quick look at pre-processing. And then what I'm going to go ahead and also show you before we get back into TensorFlow is how you do this in cloud. And I'm not going to run this. I'm just going to show you sort of a pre-run that I did earlier today. So I'm going to go ahead and specify a few things like which project and things like that. And I'll show you a little bit in Cloud Console as well for people who aren't, who haven't used Google Cloud. I'll show that. So let me show that actually. So here instead of using local files, I'm going to go ahead and specify my source data happens to be in Google Cloud Storage. So that's where the pipeline is going to run in the cloud. Dataflow is going to manage sort of the virtual machines that are used to go run this. And then instead of the direct pipeline runner, I'm going to use Dataflow pipeline runner and tell it the same preprocess. It's going to go off and run, and that's what this looks like. This is that graph. Again, sort of similar to Tensor Board, this is the graph in Dataflow world. It has a few steps: read training data, read evaluation data, preprocess, and then go right out. And the interesting thing with preprocess is it does a bunch of things. And scroll. It looks at analyzes your data column by column, and that's what Dataflow lets you do. And that's what this particular line in the CloudML SDK, this particular transform preprocess, is a sort of a larger operation that's made up of smaller operations that go look at analyze each column, figure out a min, max, mean, that type of stuff, right? So at the end of this, what I have is those same TF record files, but now in cloud storage. Now when I build a model that I want to train in cloud, I can now refer to those, and we'll see that in a second. Any questions?
So I have a question.
Yeah.
Earlier, you talked about the misclassification. So is there a way you can break it down and identify a certain portion of the tensors that causes that misclassification? You can go back and read some of the
So the question was, how do you go back and understand what's happening in your graph that caused that misclassification? There are certainly techniques that you can use in terms of, looking at different tensors. What were the values of the tensors for individual data points? Think of it as that Tensor Board view when you feed data, and you can sort of see what's happening to each of those tensors. And so that's sort of a way to kind of go about understanding what's happening in the graph. But oftentimes what you also do is, when you have lots of data and something's going wrong, you look at which data was not being predicted correctly and try to understand what's going on and seeing, are you missing something in your model in terms of accounting for sort of features that are there in your data, and sort of going back and sort of adjusting your model itself. Okay, so let's look at training. So now I'm going to show you a bunch of TensorFlow code, and you'll be able to see it sort of at your leisure, but I'll point you at interesting points. We have a framework in TensorFlow called TF-Learn, which tries to give you higher level APIs and models. And so I'll point you at, there's a little bit of code. We're trying to work on simplifying that. But this is these interesting lines. What I want to build is a deep neural net classifier. And I'm giving it number of hidden layers that I want, the hidden layers that I want, and the number of classes that are there in my data. And this will build me a TensorFlow model similar to all of this graph sort of code that I was previously building by hand. All right. So I'm going to go ahead and create this this code. And effectively, what I just did in Data Lab is define a Python module named task, and that's going to be my main module. I only have one of those in this particular sample. So think of this as a task.py file. It's in a notebook, right? And then what I'm going to go ahead and do is run training again locally. So we have in Data Lab a command called %ml train, which allows you to say, run my model through this sort of training process with this data, as well as any other sort of variables that you have in your program. So I've got like a variable that says, how many steps do you want to run? And I've parameterized that. So I can go ahead and run this. This will start. This is all running locally in TensorFlow on your machine. And as it's running, it's going to produce output. And you'll see it's sort of running, 10 steps. Every 10 steps, it's burning out some stuff. And so this is sort of this iterative loop that's happening for those 2,000 steps. And you'll see it continues to go on. And we'll just wait for it to finish. Behind the scenes, what this model is doing is exactly the same thing I showed you before. Creating a session, building a loop, feeding data through it, and then updating the weights and evaluating the model as it goes along. And so what you can also see this printing out as loss over each step. And each step is reading a chunk of data. We're almost done. Steps. Almost there. There we go. Almost there. Okay, so job finished. And if I print out the outputs, this is sort of the outputs of this TF-learn model. And so in the previous example, I didn't actually persist the model out onto disk, right? It's sort of all in memory. And at the moment I close my notebook, it's gone, all that learning. But in reality, what you also want to do is save out those learned weights so that you can load them back up when you are going to do some prediction in a different process or on some other machine or what have you. So this is sort of the exported checkpoint, which contains all those weights. Some metadata, which is contains actually the graph information, as well as this metadata YAML, which contains the description of your data, so that you can apply the same transformations at prediction time. So let's actually start Tensor Board again here. And so it's the same thing, except you'll see that with TF-learn, it actually is a much more sort of sophisticated framework. It does a lot more things. So it has a lot more sort of metrics, but the standard things like accuracy, loss are all there, right? It actually builds a much more sophisticated graph as well. So you can see it sort of does more. It's actually building a deep neural network, not just sort of a simple linear model, right? Okay, so now what I've shown so far is, let's just recap. So going from basic tensors to building a model, and I used just sort of raw TensorFlow APIs. Then I used TF-learn, which is a framework on top, to sort of more easily define a model. I've written it in a Python file effectively, and now what I can take is this. I can take this Python file, package it up into a Python package, and ship it to the cloud, and say, go run it for me. Right? That's what we want to do. So again, we have commands that let you do that easily. So ML package, sort of all this stuff is alpha right now, so ML alpha package. This is where I want this package to be written out. And then I'm going to go take this package and copy it up over to Google Cloud Storage, where my machines in the cloud can access that package. And then just like ML alpha train earlier that I used to execute this, I can take that same command, put cloud on it, go ahead and tell it which package to use, same arguments, and then I can also tell it where to run this. So Google Cloud has various regions like US Central, Europe, and so on and so forth. I can tell it where to run, and I can also tell it which scale tier. And so cloud machine learning offers different scale tiers in terms of size of your machine learning cluster. For this iris sample, just a single worker is probably enough, and so that's why scale tier is basic. And when I run this, it will go ahead and send the code over, and Cloud Machine Learning will start up resources, VM resources, run your code, and take care of training for you. So let's look at some logs that get produced from this. So all those logs that were being printed out to my sort of console in the notebook, when you're running this in cloud, you now get to see this in the Cloud Logs viewer. And so this is the Google Cloud console. This is where you get to work with all your cloud sort of resources and manage them. And one of the things we have is a logs viewer. And so it's the same set of logs here. And so what this really helps you is, when you output debug sort of statements in your training code, you can come to the logs viewer and actually see what's going on. So let's go back to this. And then let's look at what it outputted as part of this run. And again, I'm sort of listing the contents of this Google Cloud Storage bucket in a very similar way that I listed the local file. And you can see it produces the same things. So one of the key things here to take away is we expect you to be able to use TensorFlow locally to debug your code against sample data, and then take that to cloud and run it in a very similar way, right? And use all of the capabilities of TensorFlow, but on a cloud. Okay, so for the next step, last step on this one, we want to actually do something with the model that we trained. So let me go ahead and just run this. So just like ML, percent ML alpha train, we have percent ML alpha predict. And here I've given it 2 instances. And the path is this local model that I trained, right? It's going to run it through the same sort of thing. It's going to load the sort of graph, load the checkpoint, run this data through the graph, produce predictions, and dump them out. So the predicted label and the scores. Now on cloud, we have the same sort of thing. You can deploy your model. So this command takes your output of the training job that I just showed and says, go ahead and create a model and deploy it. And what happens once you've done that is, let's go to my console and let's look at my project, machine learning. So once I deploy, it shows up in my list here, Iris, as a model that has version 1. And once that happens, what cloud machine learning does is it creates an endpoint, an HTTP REST endpoint that you can sort of send it requests and get predictions as response. So let's see that in the notebook. So I'm going to take this input data, 2 instances, right? And I'm going to percent ML alpha predict, and here with the -- cloud that says go hit the cloud endpoint. It goes, hits that, produces predictions. So what just happened here? You took this output, deployed it to cloud. The cloud machine learning brought up serving instances, so it manages sort of web front ends. Automatically sort of spins them up when you have traffic, spins them down when you have no traffic, scales them up based on sort of the load, without you having sort of to manage all of those sort of operational details, right? So you get to focus in your model, you get to take your model and sort of make it be ready for productionization. Right? So now you can write a client app, whether it's sort of a web front end or a mobile app or what have you, and actually make these calls and use your model in an actual real application. All right, so that's sort of what I wanted to show, but I will show you one other thing. We obviously launched Iris into cloud, and that's like with one single worker, and that's not necessarily the best sort of showcase for what you might be able to do in cloud. The whole point of cloud is to scale up and train with lots of data. So I'm just going to show you in the console one of the jobs that someone ran earlier, and this is a model that we run internally, so to do some benchmarking. There's different versions of this, like a 10 gigabyte version, a 100 gigabyte version, and a larger one with a terabyte of data. And instead of that basic tier that I sort of used in my Iris model, I'm going to use custom, and I've chosen 140 workers, 23 parameter servers, and this is sort of using more and more of the TensorFlow machinery to do distributed training across several workers, synchronize the weights that you're learning using those parameter servers, and then be able to write all of the results back out. And so the whole idea is to be able to do more, scale more, use all of your data, and that helps you get better models. And you can see this is a much more complicated sort of program. It has multiple packages that it needs to load up into your into sort of the training program. It has a lot more arguments. And so the key point here is you've got the full power of TensorFlow and your Python code to go define graphs. You do that in Python, and then TensorFlow is sort of optimized distributed runtime for training those models using your data. And here's sort of the logs view for that particular job. And you can see, it's whether you're doing something large scale, like super large scale, or something super small scale, like Iris, it's the same set of tools. So the learning to build up sort of also help you scale up. Here I'm looking at the logs, and you can see it's logging out global steps per second, and so that's like logging the throughput, so 100 steps per second on this particular replica master. And you can look at logs for all of your replicas going on in sort of in cloud. So this gives you a sense of what you can do with taking this sort of stuff you learn and build locally and bringing it to cloud. with that, I'll hand it back to Craig, who will talk about taking this further to practice.
All right, can you still hear me? And I promise this is not usually my way. I will try to keep it nice and short. So we've talked through this, right? We've got TensorFlow. I spent a while talking about adding. Nikhil did some nicely fancier stuff, right? And we talked about the fact that you can use this all locally, and you can use this on cloud, right? But TensorFlow itself is, has many moving parts. We've stressed this a couple times. I'm going to throw enough icons on a slide to at least convince you that there are a lot of moving parts that you might want to know about, right? And so, I just want to say sort of a few words about why this is relevant, right? So what's going to happen is you are working locally, you maybe even deploy to cloud, you get a model trained, right? But there are so many other moving parts to the system, right? So Google, one of the things that we've done for a long, long time is build and deploy machine learning models on technology that predates TensorFlow, on TensorFlow, all of these, right? And so one of the things that, one of the reasons that sort of the TensorFlow team started building it in the first place is because, they wanted to solve a lot of the common problems that came up in all of the systems that we had interacted with before and make it so that, of course, we will build the perfect system, right? We're not quite there yet. But, to put a lot more of the hooks in place so that we can sort of build out a full-blown ecosystem on which you can do all of the pieces that you need, or, as many as you could reasonably hope, with this same tool chain and with these, parts that relate to it, as we can. So there's a paper written by a bunch of Googlers that, if you like reading random machine learning papers, this one has very few symbols and many more words, right? It's a fun paper to search for. If you search for it a few times, it'll do interesting things to your search history. It's about basically a bunch of folks who ran a lot of the core ads and search pipelines for years. They looked back and said, sort of, what are the common lessons we can take away about things that have gone wrong in ways that we really didn't understand going in? And they sort of recast these in the framework of technical debt, but technical debt for the world of a machine learning system, right? So it's a nice paper, but there's this quote that I want to call out that I've seen other people call out variations on, right? So it may surprise folks to know that basically 5% of what you're doing is fancy math, and 95% of what you're doing is plumbing and machinery and monitoring and deploying and serving and all of these things, right? So I can see some of you nodding your heads because you've done this, yourself. And if you haven't, I can assure you this is entirely true, right? Nobody, at least if anybody knows secrets that make that not true, I haven't heard it yet, and as soon as I do, I will, be really excited. So there's a link down there, but if you just search for this, you'll find it fast. There are a lot of these things that happen that, they talk about here and that people talk about in other places, right? So I want to talk about sort of a bunch of them in sequence, but I want to call one out because it's one that is so important that it's worth noting. And it's one of the things that the TensorFlow folks are sort of trying to attack, right? So the traditional model of how you do things, right? Everybody likes to joke about this, analyst writes their model in R or Python or MATLAB or whatever your favorite language of choice is, right? And then they get it all running, they can experiment with it locally, maybe they can sort of bootstrap up a little bit, and then what happens is they then hand it off, they're like, okay, this works, I know it's good, and then they hand it off to a dev team or whoever it is, who then basically takes it and re-implements it in a different language on top of their existing serving infrastructure because that's sort of the paradigm in which most companies work, right? You sort of have your little silo of analysts and your little silo of production engineers, and never the twain shall meet, right? So one of the things that TensorFlow focuses on, you can sort of see this in what Nikhil was doing, right? So there is, you can basically take the thing that you wrote, that you were experimenting with locally, and you just twist a few knobs, and suddenly you are no longer just playing a little game with your tiny little code, right? You're in fact running this on serious hardware or on a bunch of machines, or whatever the case may be, right? So I'm sort of pointing out a couple examples here, right? Let's say you've got a fancy GPU in your machine, or you have a friend with a fancy GPU, right? What you do is you just tag this little thing on when you're setting up your session. You say, hey, actually I want the device for either this. I mean you can configure these things in lots of ways, but for this whole graph, I actually want you to use this GPU. You basically wrap that around your code and run the same thing you ran before. Now it's actually going to do all of that computation on the GPU. And the way this works, and this is what I was saying at the beginning about this graph being an important thing. The way that this actually happens is, for each of those operations in your graph, right? If that operation basically represents a computation, there can be multiple implementations of that thing. One of those is the maybe it's the pure Python thing, right? More likely it's here's a little bit of C++ code that somebody wrote. Maybe it's using BLAS, maybe it's just using some hand-rolled code that somebody wrote over here, right? But for a lot of those things, there can also be implementations of these that run on a GPU, or run on more exotic hardware, or run, on Android or iOS. And so the idea is that, the thing that we've done by separating it this way is that, like, you can take that thing that you've written and actually use it in a lot of different situations, right? And this is something, it's solving a common pain point in terms of, making it so that the parts of your org or the parts of your team that should work together can do that without there being at least one kind of technical friction. All right, does that make sense? And so this is one of the things that TensorFlow does, right? And there are a bunch more, and I'm just gonna sort of give you a couple highlights, like ones that frankly are just the first ones that came to mind when I started looking. Anybody who's used TensorFlow before probably has 2 or 3 others that I'm not thinking of, right? So TensorFlow, sort of like the day it launched, right? There was TensorFlow, and there was Tensor Board, which launched with TensorFlow, right? And we opened up the GitHub repo and we crossed our fingers that nothing was broken, and we let people try it, right? And this is what was there. And minutes later, patches started coming in, right? And we realized we didn't really have a system for that, but we got it in order. New things started coming in, and all these other pieces, and some of these were sort of there from the beginning, right? Like the GPU support I mentioned, that's baked way in. We've been doing that a long time, right? But there was the other pieces that started popping up. So Android and iOS support came along, almost immediately after the initial launch, right? There's this module that Nikhil was talking about, tf.learn, and the whole sort of tf-contrib gallery, right? This is a bunch of code that's coming in that is these are things that you can use on top of TensorFlow. There's sort of different ways with which you might want to interact with your graph or with your session or whatever the moving parts are. That K is apparently the logo for a library called Keras, which is a very popular deep neural network library that now uses TensorFlow, or can be used with TensorFlow is probably the right way to say it. There are tools for distributed training. This little other icon over on I don't know where I'm pointing because you can't see where I'm pointing. This other icon over here is for TensorFlow serving, right? Which is some of the moving parts that Nikhil was talking about that you can also use just on your own hardware system if it's more appropriate for you. You can kind of mix and match these. So just within sort of the TensorFlow open source world, there are all these moving parts, and chances are for anything that you're doing, you either care about just the one in the middle or the one in the middle plus 2 random ones. But if we all raised our hands for which ones we cared about, you'd see that there's pretty good coverage around the whole board, right? It's not this is a lone thing in the wilderness, right? There are lots of things that this integrates with. And then, of course, working at Google, we are, somewhat partial to Google Cloud Platform, right? And so there are all these other moving parts, right? There's the CloudML APIs that Bob talked about at the top of the talk. There's, CloudML, the system for deploying your things. There's, there are things that are part of this that Nikhil didn't even get a chance to talk about. There's a thing called Hypertune, which is trying to do basically smart parameter optimization for you and parameter exploration. There are, there's data flow in the ways you integrate with that. There's BigQuery. There's, cloud storage. There's sort of all these moving parts. And the idea is that, as compared to sort of other situations where it's here's my lone silo and here's my other lone silo and you get to glue them together yourself, which is how it's operated for so long, right? The idea is that TensorFlow is this hook for here's the thing that you can use that you can sort of connect to the other things, and it should be a thing that makes it easier for you to solve more and more parts of that sort of initial loop that we were talking about at the beginning, where it's I want to do this thing, I need to change how I'm doing it. Oh, hey, here's a piece I can use. Oh, hey, here's another piece I can use. That make sense? All right, and with that, we will say thank you. So, we will skip, we'll come up here and answer questions for the whole room at once for a minute or two, and then as soon as you run out of steam, we can stick around for a minute. I put various contact information. Apparently there was some confusion. Those are intended to be Twitter usenames, but Bob doesn't have a Twitter username, so Bob and then 2 Twitter usernames. If you want to find Bob, you've got to just come find him. It's the only choice. So, yeah, you guys want to...
I have a mic if anybody wants to ask a question.
Woo! Oh, Ali has 2. Yeah. Oh, we'll get you. Do you want this one? I can grab one.
Who's got a...
There's a question right in front of you.
Oh.
Or over there.
Yeah. Yes, it's definitely possible to use multiple, so if you saw, even in the syntax, it was /GPU:0, right? We wouldn't have put that in there if you could only use one, right? You can do things you can definitely do it by choosing yourself how to do things, right? You can say these operations should happen on this GPU, these operations should happen on this GPU. And if you don't want to do that, there are hooks, and I'm going to say very clearly, I know that they exist, and I can't say I've ever looked at them, but like there are hooks to say like, I will let you decide how to use these machines, but I think it might still be mostly like you get to pick and choose and say, do this over on this GPU, do this on this GPU, and then combine it after the fact. I mean, so the question was, sort of how do you compare TensorFlow to other things? I don't necessarily have I would not want to be in the business of trying to sort of draw up a grid. I'm just going to try and dodge the question. It's my best answer.
Hi, so my question is, so obviously we all know that you can utilize notebook on virtual machines. So I'm wondering, like, compare with the way that you still deploy the code on the Google platform. What if you just go to a Google Cloud platform and open a VM and do the notebook over there? So what do you see so I can see that you're trying to do some integrations with the cloud platform with the notebook. But how do you see the difference, and what do you think the advantage, and why do you do it?
Well, we're actually actively working on this and trying to simplify how you use it. And we want to give you choice, right? So today, you can run the Data Lab sort of entire system all locally and connect it up to cloud or work with local data, as well as run it on a virtual machine and connect up to that and have your sort of notebook run close to data in cloud. And that's just sort of the starting point. We're just sort of actively working. In fact, Craig and Craig's team and my team are actively working on making this as streamlined as possible, because what we want to let you do is get into your notebook and start working with the data and not have to sort of bother with sort of how to get that in the first place. But that said, running this is sort of fairly straightforward. It requires you to have Docker locally if you want to run it locally. And it's sort of like there's a couple of steps, but you now have the choice of where you want to run it.
But I mean, another, just a very simple thing is one thing that it gives you right now is it is easy. So for instance, you saw, we just loaded up TensorFlow and a bunch of other libraries out of the box. It at least gives you a simple way to say hey, look, here's a common, container which has a bunch of stuff that we can all share, right? So there's no longer the hey, I tried this locally and then I handed it off to you and you had to spend 20 minutes emailing me to figure out which versions of which libraries I had, right? This is the first kind of thing that you get by it's really just sort of moving from I do it all by hand to manage. It's a trade-off, right? Sometimes it's not worth it for you, but most of the sort of ease of use and smoothness, there are some to start with and they just keep growing over time.
So assuming you have Docker on your machine, this is sort of the command. And I run this all the time because guess what? I don't have to deal with installing Python or any other libraries. It's just all there. So that's sort of the one command to get me started. There's a question up front here.
Yeah, quick question. One, do you think it would be possible to share any of the notebook code that was used in the presentation tonight?
Absolutely. Yours is shareable.
Yeah, I mean,
I can share.
Or even just the Docker code.
I will share. I can share my notebooks. I will.
I'll include mine.
And folks who don't have Google Cloud, actually I should have asked this. Has anyone sort of used any of the Google Cloud stuff? So you can start running this locally as I was doing. You don't, it's just using Data Lab and TensorFlow locally. But if you want to run it on cloud, you will have to sort of have a cloud project. Absolutely, I can share.
Thanks. And one follow-up question about GPU integrations. Do you know if there are any current GPU integrations for OpenCV? I know that the NVIDIA stuff is very, very popular and well supported across a lot of the different libraries, but some of us who have newer MacBooks only have OpenCV to use with our GPUs, so I'm just curious.
So the little bit I know, 5 minutes after the TensorFlow repo went live, people started asking questions like that. And it's some mix of there are some of these that we would like to support and simply just don't have the manpower for. There are some of these where we didn't know they existed. I mean, this one we knew about, right? But the thing I would do to start answering that question is just go search the GitHub issues for TensorFlow, and you'll at least see almost always there's a sort of a master tracking issue that says here's a plan. We need people to fill in X, Y, and Z, and here are some pointers, right? A comparable question that people may be about to ask is what about I love the idea of TensorFlow, but I want to work in language Y instead of Python, right? It's the same thing. Like some of these are pretty mature. Like there's RStudio is building one for R, for instance, right? And you know, some of these are pretty far along. Some of these are more like there's an issue where people were like, cool, me too, and that's all that exists. So
I just brought up the GitHub page, and you'll see it's like really active. There's tons of issues, tons of pull requests, and lots of like forks, and
yeah.
it's really active.
Yeah, so I mean, I hinted at this before, but just to call it out, like, for most of the heavy stuff, you're actually running in C++. You use Python as sort of like the goo on top with which you describe things, but it's also, you know, I mean, for a lot of the stuff you do, I mean, Python is a good fit for like, there's a heavy thing I have to run over here, and there's a heavy thing I have to run over here, and I want to put those together super fast, and I want putting those together to get out of my way, right? So like that's Python at a glance, you know, for some subset of Python use in data analysis.
And so one of the things I didn't highlight in the code, the very first code that I had was Python code loading some data and feeding it into the graph, right? So you had Python play a sort of fairly active role, but in the sort of cloud version of this, the way it was set up was Python code says, set up a queue, here's my files on Google Cloud Storage, here's the parsing sort of set of operations to do in the graph, and then go, right? And then Python is effectively out of the loop, right? So at that point, all of this is sort of happening in sort of C++ written code.
Thanks. So you did mention both tflearn and the Keras package, which has also become a popular high-level interface for working with TensorFlow. I was just wondering, since the lead developer of Keras is also part of Google Machine Intelligence, how do those two different projects position with respect to each other? Are they trying to accomplish different goals or similar goals?
I mean, I'm not going to claim I can speak for either one of the groups that are in charge, right? I think that the sort of model here is like folks are happy to sort of let 1,000 flowers bloom, right? Like if you have a way that you want to construct or interact with or describe neural networks that is different than what either one of these do, that's great, right? Like, you know, I mean, part of the goal here is that like Keras, by adding support for this, was able to take advantage of like all of the guts underneath without having to re-implement that all, right? So like, I mean, by and large, people are just like super happy for people to be using it if it's a thing that makes you more effective at your job, right?
But
So
there's nothing about tflearn that's specifically trying to be different than Keras. They're just two different approaches.
Yeah, there's, you know, you can imagine sort of, there's different frameworks, all of them have different sort of opinion styles. And again, the key thing is this graph, right? Regardless of sort of which framework or which sort of APIs you use, you're constructing this graph and then telling the TensorFlow to compute that graph. And speaking from a cloud machine learning point of view, we would, you know, love for people to, you know, use their favorite framework and bring it to cloud, right? So, it's what you like.
So I was wondering, you mentioned about parameter optimization, right? Is there some sort of optimization that Google platform or involves for like defining what sort of workers that we need for running a model computation or for running a prediction?
We're working on that in terms of, this is sort of, as you can imagine, this is sort of one of the interesting frontiers on machine learning, which is trying to understand what's the best sort of resources to apply to this problem, right? And that's sort of an active thing that we're sort of working on in terms of in cloud, you know, not just let you pick number of workers, but give you some clues on and how your training is happening. But you brought up parameter tuning, and I do want to actually show you something that we have. One of the samples that we have in Data Lab. And this speaks to the hypertune thing that Craig was at, except I'm not seeing it now. We have a fair number of things that Data Lab is used for. And so I'll bring up Iris, the full sample, and it's got a hyperparameter tuning sample. And here, you know, as part of my job, I'm also specifying a bunch of hyperparameters. And when that's run, the cloud infrastructure runs a whole bunch of runs, and there's some fairly sophisticated sort of algorithm behind sort of which runs to do. And these are all the runs, and then this is like way bigger than the screen fits, but you can start seeing, which different values of parameters led to what different, how quality of models and so on. This is something that's really cool that I didn't get to show.
We never did.
No, we did. So thanks for the question.
Is that good? We'll stick around for a minute if you got, one or two more little questions to ask, but.
And there's an announcement as well.
Oh.
Yeah, so there's actually another all-day TensorFlow training event in Google Seattle coming up in November 12th. I believe it's a Saturday. It's going to be 9 to 3, and it's going to be more interactive, geared towards people who may not be machine learning experts, but who have background in Python programming. We will also post that to the meetup group. Thank you.
Thank you.
Yeah.